Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 10.4, Factoring to Solve Quadratics Day 2. Remember that roots is the same thing as solutions, the same as zeros, and the same thing as x-intercepts. The first thing, if you're solving by square roots and you take the square root of a positive number, how many answers do you get? You get 2 answers. If you take the square root of a negative number, you get no real solution. And if you take the square root of 0, you get 0 as your answer, or just one answer. Okay? For example 1, what I need to do is go ahead and add 1. So 4x squared is equal to 16. Divide by 4. X squared is equal to 4. Take the square root. X equals plus or minus 2. Example 2, if I add 6, I get x squared is equal to 0. Take the square root, so x is equal to 0. And for example 3, if I go ahead and subtract 5, x squared is equal to negative 25. Square root. Since I square rooted a negative, it would be no real solution. All of that is review from what we've been doing in the last couple of units. So I'm going to go through that fairly quickly. The same with this zero property. Review solving by zero property. If A times B equals 0, then A equals 0 or B equals 0 or both could equal 0. So solve each equation by factoring and using the zero property. Factoring, review, and zero property. The first one, we're going to have a GCF. The GCF would be x, which would leave me with x minus 5 inside the parentheses. From here, I can set everything equal to 0. So x would equal 0. Then x minus 5 equals 0. Add 5. X would equal 5. For the second one, again, I'm going to have another GCF. It would be 4. Leave me with x plus 4 is equal to 0. So 4 is not equal to 0, so I can get rid of it. X plus 4 is equal to 0. Subtract 4 from both sides. X would equal negative 4. All right, try these. Find the roots. Remember, the equation must equal 0. Don't forget the first question of factoring is there anything in common? So the first problem, we have x to the third minus 14x squared is equal to 0. We already have it set equal to 0, so we can go ahead and try to factor. In this case, I do have a GCF of x squared. X to the third divided by x squared would be x. Negative 14x squared divided by x squared is negative 14. It's all equal to 0. From here, since I have it fully factored, I can set x squared equal to 0, take the square root, and x would equal 0. Then I can also take x minus 14, set that equal to 0, add 14 to both sides, so x would equal 14. All right. On to problem B. Again, I'm going to have a GCF, which would be 2. It would leave me with x squared plus 2x minus 35 is equal to 0 because I took each one of those numbers, divided them all by 2. I am not done factoring with what's inside the parentheses, so it would be 2 sets of parentheses using generic factoring. What multiplies 35 that can add to 2? That would be 7 and 5, so I'm going to have x plus 7, x minus 5. Everything needs to be set equal to 0. 2 is not equal to 0, so I can get rid of it. X plus 7 equals 0. If I subtract 7 from both sides, x equals negative 7. X minus 5 equals 0. If I add 5 to both sides, then x would equal 5. That'd be the end of that problem. On to part C. X to the third minus 100 times x equals 0. Again, I'm going to have a GCF of x, which would leave me with x squared minus 100. All that's equal to 0. X squared minus 100, if you remember from our previous units, would be the difference of 2 squares. It would be x plus 10, x minus 10. Now that I have everything fully factored, I can go ahead and set them equal to 0. X equals 0. X plus 10 equals 0, so subtract 10. X would equal negative 10. X minus 10 equals 0. Add 10. So x equals positive 10. There's a little review there for you on factoring and solving with the zero property. In part D, again, just like on the front, we need to set everything equal to 0. So I have x squared minus 12x. I needed to add the 36 over to get it set equal to 0. From here, I can use generic factoring. Well, what multiplies to 36 and can add to negative 12? It would be x minus 6 and x minus 6. Because those are the same, I can do x minus 6 equals 0. If I just add 6 to both sides, x would equal 6. All right, on to part E. First thing, we have a little bit of an issue, a little bit of a typo. Let's make that a positive 42. If I subtract 42 from both sides in order to get myself to 0, I would have x squared plus x minus 42 is equal to 0. How do I multiply to negative 42 and add to positive 1? It would be x plus 7 times x minus 6. From here, I can set everything equal to 0, so x plus 7 equals 0. Subtract 7. X equals negative 7. Then I have x minus 6 I can set equal to 0, add 6. So x equals 6. All right. On to part F, I have 3x squared minus 5x plus 2. I would look for a GCF, but I would not find one. In this case, I can use generic factoring to get myself to that location. It would be 3x and x. I would need to get to negative 3 and negative 2. So to get 3x to negative 3x, I would have to multiply it by negative 1. To get x to negative 2x, I would have to multiply it by negative 2. So from here, I have it fully factored. I can go ahead and set these each equal to 0. So I'm going to add 2. 3x equals 2 divided by 3. So x equals 2 over 3. Also, I have x minus 1 equals 0, so if I add 1 to both sides, x would equal 1. All right, now on to applications. Applications are going to be a little bit different. I know that you did some of these for an assignment not too long ago, but let's talk about it. The sides of a square are all increased by 5 inches. The area of the new square is 196 square inches. So what it's saying is that my side of my square is going to be x, and then it increases by 5 inches. Since all the sides of a square are the same, I'm going to multiply that by itself in order to find my area. So x plus 5 times x plus 5 would give me my new area of 196. Well, x plus 5 times x plus 5 can be rewritten as x plus 5 squared. From here, I can get rid of the squared by taking the square root, which would get me x plus 5 equals 14. At the end, it tells us to find the length of a side of the original square, so I'm going to subtract 5, because it told us originally that I had a side that had increased by 5, so then 14 minus 5 would get me 9 inches. Okay? The product of two consecutive integers. So what we need to realize here is that x is my first integer, and x plus 1 is my second integer. So that's my second integer. X is my first integer. So the product of those, x times x plus 1, means equals 3 less than 5 times the smaller one. Well, since this is x plus 1, my smaller one will be my first, or x. So 5 times the smaller one will be 5x, and then 3 less that, so I would subtract 3. Okay? In order to make this work, and especially the way we've been doing things, I need to be able to get everything to 0. So what I'm going to do is distribute. So I get x squared plus x equals 5x minus 3. To solve this, I need to subtract my 5x and add my 3 to both sides. So I would get x squared minus 4x plus 3 equals 0. At this point, I can go ahead and factor using generic factoring. Be x minus 3 and x minus 1, because negative 3 times negative 1 gets me positive 3, and that also adds to negative 4. Now that it's fully factored, I can take x minus 3, set it equal to 0, add 3 to both sides, x would equal 3. X minus 1 is equal to 0, add 1 to both sides, x would equal 1. That is the end of our lesson. Most of this lesson should be reviewed for you. The only things that might be a little bit different are the applications, and really if you can just slow yourself down and think through the problem, I don't believe they should give you too many problems. If you have any questions, please make sure you come in to see me. Otherwise, thank you very much for watching the video, and have a great day.